To start this video off, we're going to look at simplifying rational expressions. And since you've learned this before, we're going to go through it kind of quickly. So if you guys recall what rational expressions are, a rational expression is going to represent the division of two functions. So these are written as fractions. So the first operation that we're going to look at with simplifying is if you are multiplying or dividing. So here, for example, I'll go ahead and write that down first and then talk about it. Let's say we have x squared plus 4x minus 5 over x minus 1. And we're multiplying that by x squared minus x minus 12 over x squared plus 12x plus 35. While multiplication and division are inverse operations, so when our whole problem only involves multiplying and dividing, all we want to do is cancel as many things as possible. So anything that's been multiplied and anything that's been divided can cancel. And the way I think of that is a top and a bottom can cancel. No matter where they are in the problem, they can cancel because this is a multiplication and division problem. So what I want to look at here is I would just want to factor everything so that I can see what things have been multiplied together. Because right now all I see on the top are things that have been added and subtracted. And so I want to rewrite it using multiplication. So for the first thing, two numbers that multiply to negative 5 and add to 4 would be x plus 5 and x minus 1. Two things that multiply to negative 12 but add to negative 1 would be x minus 4 and x plus 3. And two things that would multiply to 35 but add to 12 would be 7 and 5. So at this point, I've rewritten the whole problem in terms of multiplication and division, and so now I can cancel tops and bottoms. So these two cancel, and then this multiplication of x plus 5 and this division of x plus 5, those can cancel. And so our final answer is just the factors that are left over, and that would be x minus 4, x plus 3, and x plus 7 on the bottom. Alright, here's another example. This is a division problem, so that was two rational expressions being multiplied together that made one whole rational expression. And here I'm going to look at dividing them because they look kind of weird and they often make students uncomfortable when they're written this way. Alright. So whenever we have a division problem, we have this fraction on the top is being divided by the fraction on the bottom. And what we do is we do keep it, change it, flip it. So you keep the fraction on the top exactly the same, 3k over, and I'm going to go ahead and fix the order of the denominator of the fraction that was on top because it's in the incorrect order right now. So I'm going to go ahead and fix that. Just change the order. So I kept the top, I'm changing it from a division problem to a multiplication problem, and then I'm flipping the bottom up. K squared minus k minus 30. And now at this point, it's just like the example above. So I'm going to go ahead and factor that. So 3k, the bottom has a GCF of 3k, and that leaves us with k plus 5. And then this would be k minus 6. K plus 5, and k minus 2 on the bottom. And so again, we can cancel things out. And so this would simplify to k minus 6 over k minus 2. Alright, the next operation that we're going to look at is adding or subtracting rational expressions. And people do not like these because you must get a common denominator. So these are a bit harder. So for example, let's say we have 5n over 3n minus 1, and we are subtracting 2n over n minus 6. Then I have to look at the denominators. And the very first thing you would want to do with the denominators is factor them to see if they have any factors in common. And 3n minus 1 does not factor, and n minus 6 does not factor. So here, the common denominator is going to be 3n minus 1 multiplied by n minus 6. So that's kind of unfortunate that it's not being fixed at all. So what we're going to do next is we're going to make it so that each fraction has that common denominator. So I'm going to take the first fraction and multiply it by the second denominator. And then I have the second fraction. I'm going to multiply it by the first denominator. And you'll notice here that n minus 6 over n minus 6, anytime you have the same thing over itself, it's like multiplying by 1. So I'm changing what the problem looks like, but I'm not changing what it represents. So I haven't just like added 5 in, you know, like I'm multiplying it by 1. Alright, so the top, I'm going to go ahead and distribute that out. So that gives me 5n squared minus 30n. And the bottom I'm actually going to leave the same because ultimately I know that the other denominator is going to be identical, and at the very last step of my problem I'm going to be trying to cancel the factors. So that's why I'm going to leave it like that. The top I'm going to have to combine some like terms, which is why I have not done that yet. Okay, so minus, and then over here we still have the same common denominator. I'm going to go ahead and write it in the same order. And then we have 6n squared minus 2n. Okay, so now we've got that common denominator, 3n minus 1, n minus 6. And I have 5n squared minus 6n squared, which gives me negative n squared. And I have negative 30n minus negative 2. Which gives me a plus 2, so that's negative 28n. Alright, and then I'll factor the top just to see if anything will come out of that. So I'm going to take out a negative n, and that gives me n minus 28. And as you can see, nothing cancels. And that is my final answer right there. Alright, one more type of simplifying. So here, these are called complex fractions. And we want to pay special attention to these because they show up in calculus a lot. So this is a good one to kind of pay attention to. So complex fractions are like fractions within fractions within fractions. So we have u squared over u minus 2. Plus u minus 2 over 3u, all divided by u. And the first thing that I want to do here is I want to rewrite the problem so that everything within the problem has a numerator and a denominator. So I'm going to go ahead and add that this one right here is over 1, like that. Okay, so now I want to figure out what my common denominator is. So this one has a denominator of u minus 2. This one has a denominator of 3u, and this one has a denominator of 1. And those denominators cannot be factored at all, and so my common denominator is going to be u minus 2 multiplied by 3u. Alright, so what I'm going to go ahead and do is I'm going to rewrite this problem out, u squared over u minus 2 plus u minus 2 over 3u, and that's over u over 1. And now I'm going to take this whole thing and I'm going to multiply the top by u minus 2 and 3u, and I'm going to multiply the bottom by u minus 2 and 3u. And you could, what you could have done is you could have gotten a common denominator on each one of these, kind of like we did on the previous example, and then you could do keep, change, flip. So that is always an option. But this way, I was looking through the calculus teacher's notes, and she did it this way, and it made the whole process a little bit quicker for this, which is why I'm showing you how to do it this way. Okay, so what we're going to do is we're going to distribute the top to each piece. So if I take this and I multiply it by this piece right here, what you'll notice is that we have u squared over u minus 2, and we're multiplying that by u minus 2 and 3u. And what you'll notice is the u minus 2's, they cancel. All right? And then again, I'm going to take this and distribute it to this piece. So I have u minus 2 over 3u, and I'm multiplying that by u minus 2 times 3u. And you'll see these two cancel. And then on the bottom, so here's my huge, that was the top of the fraction, and then on the bottom I have the u over 1, and I'm multiplying that by u minus 2 and 3u, and nothing cancels, so we really truly do just have to multiply all of that. So now I'm going to go ahead and continue simplifying what I have. So right here I have u squared times 3u, and that is going to be 3u to the third. So that takes care of that part. And then I've got a plus, and I have u minus 2 multiplied by u minus 2, and those are going to need to be FOILed. So when I FOIL that, I get u squared minus 4u plus 4. And then I need to multiply this part on the bottom. So what I'm going to do is I'm going to multiply these two things together first. I have a 3u squared, and that's being multiplied by u minus 2. Alright, and again, I'm going to go ahead and leave this in this factored form on the bottom because I want to see if it's going to cancel with the top. Alright, so I've got on the top 3u to the third plus u squared minus 4u plus 4. And then on the bottom I have 3u squared and u minus 2. And what I would look to see is if maybe the top could factor, and the top is, it looks like a classic factor by grouping problem, but if you look at it, if you started to factor it, you would not find that it factors. It just doesn't. And so we're going to go ahead and say that is our final, most simplified answer right there. Okay, and then very last thing we're going to do here is we are going to solve rational equations. So we're not talking about expressions anymore. We're talking about equations now, so we're going to have an equal sign. So we're going to say we'll have 1 over n squared minus n minus 20 minus 2 over n minus 5 equals 1 over n minus 5. So since this has subtracting, right here, if we cover this up, we're subtracting rational expressions right here, which means we need a common denominator. And to figure out our common denominator, we need to figure out what the factors of this are so we can see what all the pieces in the denominator are. So this one right here would be n minus 5 and n plus 4. And then n minus 5 and n minus 5. So we know our common denominator should have n minus 5. And we're also going to need it to have n plus 4. Now, when we look at solving rational equations, we are going to have specific values that the equation cannot equal because, and it's going back to that idea of domain, because it would make the bottom of the fraction equal 0 in the original problem. So if we look at this problem right here, automatically we're going to know that n cannot be 5 and n cannot be negative 4. So once I finish the problem, so long as I do not have those two as an answer, then I know my answer is valid. Alright, so I'm going to go ahead and rewrite this. I have 1 over n minus 5, n plus 4, minus 2 over n minus 5, and then I know I'm going to need to multiply this by n plus 4 over n plus 4 to get that common denominator. And then over here I have 1 over n minus 5 times n plus 4 over n plus 4. And actually the nice thing about solving rational equations is that once you know you have a common denominator, you can just ditch the denominator because it doesn't matter in the problem. We're just going to solve the top. So we're just going to ignore all of this stuff right here. So notice I did a really good job of showing my work before I ditched the denominator. That helps me just make sure that I'm going to get the answer right. So 2n plus 4. I find that when students shortcut their steps on these problems, they often make little mistakes that ultimately make them get the problem wrong. So I've got 1 minus 2n minus 8 equals n plus 4. And I'm going to go ahead and combine like terms on the left side. So I have negative 2n minus 7. And then I'll go ahead and move all my n's over to the right side. So I have negative 7 equals 3n plus 4. And minus the 4 over. And then divide the 3 over. And negative 11 thirds was not one of my values that needed to be excluded, and so that is a valid answer.